All right, in this demonstration, we will use the Aircrack suite to attack a wireless access point with WEP key encryption. We'll start by typing airman NG, just to make sure that the wireless interface is hooked up and detected by the Linux machine, and that it is on wireless LAN 0. After that, we will use the same command, airman NG, and type here, start wireless LAN 0, and press enter. The monitor has been enabled now, so what this command does is it puts the wireless LAN on a monitor mode and it's been set up on monitor 0. This is also telling us that these three processes might cause some trouble in the future, so let's just kill them right now. And while you're doing so, remember that you must use a wireless interface that has enough power to inject packets to the access point and to listen to the access point. So for this demonstration, we are using an alpha card with a 5 dB antenna. So we have killed all the processes. Now we can try to use the wireless interface to listen to the wireless around us. So I'm going to go ahead and type airodump NG now and type WLAN 0, hit enter, and then we'll see what access points are available to us. Now remember, this demonstration is only for WEP, not for WPA or WPA2. So we will look here at the encryption and decipher and detect which ones are operating on a WEP key. We have many of them operating on a WEP key, it looks like, but we won't be violating any laws by attacking someone we don't know. So there's some good news. So let's see, we've set up our WEP wireless access point, which is right here. dlink_guest, and we need this MAC address, so I'm going to stop the scan for just a little bit just to copy the MAC address. That's all I need to do. This is the MAC address that we want in a later command, and so I am going to copy it and keep it on my clipboard. Now notice here the channel of our access point is channel 10, and again a WEP key, WEP key. Here is the number of data, number of packets transmitted per second, and the beacons. Now these numbers are 0 and 3 because there is no request on that access point. Either there are no computers connected to it or they are just not using the network. All right, so just continue having the Aircrack suite scanning and we'll open a new terminal. And in this terminal we will use the same command, airodump NG, and specify the channel for that access point. Now just to make sure we will not write anything wrong here, it is working on channel 10. So -C, specify channel 10, and specify a capture file by the W switch. So -W and the file name that the wireless data will be captured to. I'm going to call it capture or capture 1 so I can recognize it. So at this point we need to specify the MAC address of that access point by typing here BSSID, and just to be clear that it's BSSID, good, and paste the MAC address. Which monitor we are listening to, that access point is monitor 0, the one we have started just a few minutes ago. Press enter. And see, there it is. The wireless interface is listening to that access point. It's on channel 10. It has WEP encryption, and there is no data currently. Now for this, I am going to do some internet requests on a computer connected to this access point, just to get something, just to kind of show you what we can do here. And there we go. We can see that the data is going up. Now in order to continue, we need this number to be really high. We need this number to reach 20,000 to be able to continue with the attack process. So I have paused the video for a minute, and the data has reached almost 1,200 packets. And while we are waiting for the data to reach the number we need, we are going to proceed with some different commands. Okay, so let's minimize this one and put this one here, and we'll take the new one aside. Move it over so we can still see the data number. There, that's better. Now here we will type another command, airplay. We're going to use airplay NG and specify -1 and then 0. The option 1 we have mentioned is for association. We need to be associated with that access point. And if I switch the 0 to 1, actually let me show what does 0 do, and later I will show you what happens if I switch it to another number. So -A, and paste the MAC address of the access point, and then type monitor 0 and press enter. Now check out what's happening now. We are at this moment sending authentication requests to that access point. Authentication successful. We will keep trying to send authentication until we get something called associated or association successful. Once we get an association, this command will stop. But you'll notice if I switch the 0 to 1, it will keep trying to associate even after getting a complete or successful association. Like this association has been successful, but if I switch it to 1, and at some point you will need to do this, it will keep trying to associate. So time after time, one after one, so a flaw, it looks like, has been detected. The monitor 0 is on channel 8, but the access point is on channel 10. So let's try again. Now this happens because the access point sometimes changes channel. Monitor 0 now is scanning all the channels, so if I stop this one, it will help me a little bit more. This isn't the final solution because this command, the tool here, is scanning different channels. So you might have this issue sometimes, but that's fine. Now you can just reinitiate the command, and once it's started, it will keep going and going. And you notice that this is helping us, and the number of data is going up. Let's keep this one running. Minimize it if you want. Open a new terminal here. In this terminal, we will use another AirPlay command, Airplay and G minus option 3 here, -3 and -B for the MAC address. I'm going to paste the MAC address, and of course, we are working on monitor 0. As per usual, and hit enter. All right, now what we want to do here is get an ARP request. We are getting the ACKs and we need at least one ARP request. Again, we need this number to be high enough, and we need an ARP request here. So it's reading the packets. When it gets to one ARP request, we can then try to crack the encryption key. Until we get the ARP request, we can't really do anything. So we'll just wait on that. Now I'm keeping some stuff running on a computer connected to that access point just to support this hacking process. In a real world scenario, you will have many people connected to the access point and there will be no wait time at all. You will see that 20,000 comes within 1 minute or less. All right, so you will have one client disconnect from the access point and connect again. And this can be accomplished with another command to deauthenticate the client, and then they will authenticate back again. It's kind of like initiating a DOS attack against one client. And then they will connect again automatically, or keep waiting for the data until you have enough data and ARP requests. At this point, I'm going to pause the video a few minutes until I reach a high enough number for the data, and then we'll come back to you in a moment. All right, we've taken a few moments. We now have almost, look at 22,000, which is definitely good enough to go. So we will need to open a new terminal here and type Aircrack NG and specify the capture file. I'll type here capture 1-0. This is the file name that we had written in the first command. Specifies capture 1. Now why is there a -0? I'm going to press tab. I can see that I have capture 1 -01.cap, and I have got .csv, and I have Kismet, which is another tool that can be used here. I have the capture 1-02 and the same of everything else. I'm going to go for capture 1-01.cap and hit enter. And it looks like I've got 26 IVs. Again, that's initialization vectors, and it will try to crack the key from these 26 IVs. Notice here, failed. Try with the next 5,000 IVs. That's fine. No reason to panic. Just try the same command again. But instead of capture 1-01.cap, try it with capture 1-02.cap and see how many IVs we have. 1,950 IVs. Okay, this is enough, I think. It's decrypted 100%. So key found. This is the key and the ASCII code, which is 12345. Now this is an easy key, but in WEP encryption you have 64-bit and you have 128-bit. So in 64-bit it's going to be a small key, and it doesn't matter really what you put here, 1, 2, 3, 4, 5 or letters. 128-bit encryption will take a longer time to get the key, as you can imagine, but you will get it. Here's the key we needed. We didn't actually need the 5,000 IVs, but we needed something more along the line of 1,000 IVs. So we have found it with 1,950 initialization vectors. Now in any computer you can type in this key or this key and you can connect to that access point.
Now, WPA and WPA2 are pretty close in how they handle encryption and authentication. When cracking them, we don't look at the data count like in WEP cracking, but are instead looking for the WPA handshake. For that to happen, we will need at least one client to deauthenticate and authenticate back to the AP. We will force this to happen.